Today we're going to be looking at Learning Target 2 from Unit 7, which is I can show the decimal expansion for rational numbers. So before we start on this, we're going to just look back at some review of converting terminating decimals to fractions. This is a skill that you will have learned a couple years ago, and we just want to review that because it will come in helpful for this unit. Remember, this is our unit where we should not be using calculators. So looking at our first chart here, it says use what you know about place value to find the fraction that is equivalent to any terminating decimal. So looking at our first example here, it's 4/10, or 0.4. So our place value, we look at that very last number. The 4 is in the tenths place. So if we were to write this as a fraction, we would use that 4 and we would write it over 10 because the 4 is in the tenths place. Now 4/10, hopefully we can recognize that is not in simplest form. Those are both even numbers, so I know that I am able to divide out a common factor of 2, which would give me 2/5. And 2/5, both of those numbers are prime, or they do not share a factor other than 1, so 2/5 would be our equivalent fraction to 0.4. If we look at our next example, we have 0.75 or 75 hundredths. Now some of you might already have that decimal or that fraction memorized, but for those that do not, that is okay. We'll talk through how to get it. So the 5, that very last number, is in the hundredths spot. So we are going to take 75, which is the entire value after the decimal, and put it over 100. Now again, I can see they're not even. However, 75 ends in a 5, 100 ends in a 0, so we should remember that both if a number ends in a 5 and or a 0, we can divide it by a common factor of 5. And 75 divided by 100, 75 divided by 5 over 100 divided by 5, and even now as I'm saying this, 75, if we think money, I could divide by 25. And that will get us to our simplest form even sooner. So 75 divided by 25 is 3, and 100 divided by 25 is 4. So we get our simplified fraction of 3/4. Looking at the next example, we have 0.386. The 6 is in the thousandths place. So I would write all the digits after the decimal, 386 over 1,000. Both of those values are even, so I'm going to go ahead and divide by 2. And 386 divided by 2 is 193 over 500. And those are in simplest form, or that is in simplest form. Now my last example here, we have the square root of 0.16, or the square root of 16 hundredths. Before we put it into a fraction form, we need to make sure that we take it out of the radical sign. So what is the square root of 0.16? Well, 16, the square root of 16 is 4. So the square root of 0.16 would be 0.4. And we should recognize that that is the exact same as our first example. The 4 is in the tenths place. So that would be 4/10, which we already discovered was simplified to 2/5. So hopefully that was review and you remember doing that in years past. Our new portion for this target is converting repeating decimals to fractions. Now I'm going to be showing you kind of a shortcut way to make this all work. There is definitely a longer mathematical process to this. However, for this purposes of what we are going to get to, we really kind of just need to know those shortcut ways. I might post a video for people who are interested in learning that longer way later, but for right now, we're just focusing on our shortcuts. So, to convert repeating decimals to fractions, the shortcut way, when all of the digits are repeating. So this is when you have a decimal where every single value is repeating. If you have one digit repeating, you're going to place 1 9 in the denominator and the repeating digit as your numerator. If you have 2 digits repeating, you're going to replace 2 9s in your denominator and the 2 repeating digits in your numerator. If you have 3 digits repeating, you're going to put 3 9s in your denominator and the 3 repeating digits in your numerator, and so on and so on. So if we look at our first repeating decimal here, I see that I have 0.6 with a bar over it. This is called bar notation. That lets us know that that 6 is going to be repeating forever. So it will be 0.6666 on and on and on and on. So based off of our shortcut way, that value of 6 would be our numerator, and since it's one digit repeating, it would be over 1 9. And I can see 6 9ths, those have a common factor of 3, so if I divide 3 from both values, I get 2 thirds. So 2 thirds is the fraction for 0.6 repeating. If you look at the next example here, convert 0.9 repeating to a fraction. So that is, the repeating digit is 9. It's one digit that's repeating over 9. Now this is where it gets a little interesting. 9 over 9. When we have the same value in the numerator and the denominator, that's equal to 1. We've practiced that often and we've kind of run into that a lot. However, we're converting the decimal 0.9999 repeating forever and ever and ever. The reason that this is like this is actually considered a special case. Because 0.999 repeating forever and ever and ever is so close to the value of 1 that it actually kind of, when we put it in fraction form, becomes 1. I'm sure there is some really deep reasoning why that works, but it's just something interesting for you to know is that the fraction value of 0.9 repeating actually in turn becomes 1. It's 9 over 9, which becomes 1. If we look at our next example, convert 0.12 to a fraction. So the bar notation, notice, is over the 1 and the 2. So that means this is going to be 0.121212 forever. So I have 2 digits that are repeating, the 1 and the 2. So I'm going to be putting that over 2 9. So that's 12 over 99. I can recognize that those have a common factor of 3. So if I divide by 3, that gives me 4 over 33, which is my simplest form. And in my last example here, I have 6.123, and then I want to put to a fraction, or convert to a fraction. The bar is over 3 digits, so I know that I'm going to have 3 digits that are repeating. So I'm going to put that over 3 9s. Now the one thing I can't forget with this example is that there is a whole number in front. So I have to include that whole number out in front of my fraction and not forget to include it in my final answer. So when I get to, if I need to then reduce 123 over 999, okay, those both are divisible by 3. And so that would give me 41 over 333, which then gives me the answer of 6 and 41 over 333. And that would be my mixed number with my fraction in simplest form. Moving on, unfortunately, it will not always be that basic. Sometimes you will have values where only a portion of the decimal is repeating and not all of the digits after the decimal, and that's where you have a little bit more of an intensive process to follow. So if I want to convert 0.23 repeating to a fraction, notice that the bar is only over the 3, so this would be 0.2333333, so on and so on forever. So there's a process that you're going to follow, and I've listed out the steps, and as long as you follow those steps, you'll be golden. So our first step, identify how many digits are repeating. So I can recognize that there is one digit repeating. The bar is over one digit. So that's one digit repeating. So we are going to write that many 9s in the denominator. Okay, so I would put 1 9 in the denominator. Okay, so 1 9 in the denominator. Moving on to the next step, you're going to identify how many digits are not repeating. And so that is one digit is not repeating. That is the 2. And we're going to write that many zeros after the 9s that we had just written. So now my denominator is going to read as 90. You're then going to take the number written without the decimal or the bar with the non-repeating digits. Okay, so if I were to look back at that number, if I were to take away the bar, take away the decimal, take away the 0, I'm left with 23. And I want to subtract the non-repeated digit or digits. So in this example, the 2 is not repeating. So I'm going to take 23 and I'm going to subtract 2, and that gives me 21. And that's going to be my numerator. And we already know that 90 is my denominator. And then last but not least, if you need to, you're going to then simplify. Okay, and with this I can see 21. I know my factors pretty well, so I'm going to be dividing by 3. And so 21 divided by 3 is 7. 90 divided by 3 is 30. And I know that 7 is prime, so the only factor that those share is 1. So 7/30ths is the fraction for the decimal 0.23333 repeating. All right, so let's go through that process together on these examples that we have below. So our first example is converting 3.286 repeating to a fraction. So I notice that I have one digit repeating. Okay, so that's going, and well, first thing I should really notice is I have a whole number here. So I'm going to put that out in front and then write my fraction bar. So I have one repeating digit, so I'm going to put 1 9 in my denominator. I have two non-repeating digits, so that's going to be 2 zeros in the denominator. I now want to take my decimal, the numbers after the decimal, ignore the decimal, so I have 286, and I'm going to subtract the non-repeated digits, which would be 28, or 28. So when I subtract that, so 6 minus 8, I need to borrow a 10, so that becomes 70, this becomes 16. 16 take away 8 is 8. 7 take away 2 is 5, and 2 take away 0 is 2. So my new numerator would be 258. Okay, I can look at both of those. I see that they're both even. I also can see that if I add up 2 plus 5 plus 8, that gives me 15, and 15 is divisible by 3. So when you have a number that is divisible by 2 and divisible by 3, that lets me know that it is also divisible by 6. And unfortunately, we're not in our classroom to where you can see our poster with division rules, but maybe I can post one in Google Classroom so you have that to help you out here. So if I do that division, 258 divided by 6 is 43. 900 divided by 6 is 150. So that would leave me with my whole number 3 and 43 1/50ths as my simplified fraction. Moving on, if I look at the next example, convert 0.9724 where the 7, 2, and 4 are repeating. We're going to convert that to a fraction. So I see that the bar is over 3 values. So I have 3 digits repeating. So I'm going to put 3 9s in the denominator. I have 1 digit not repeating, so I'm going to put 1 0 in the denominator. I'm then going to write my number without the decimal in the numerator. So I have 9,724 over 9,990 as my fraction. I am then, oh, just kidding. What did I do wrong? Rewind. I forgot step 3. I need to take 9,724 and take away the non-repeated digit. This is a perfect example why you should not have your cell phone near you while you're trying to do your math work. It distracts you and you can make simple mistakes. So if I subtract 4 minus 9, I cannot do, so I have to borrow a 10 from the 2. So that makes 14 minus 9, which is 5. 1 minus 0 is 1, 7 minus 0 is 7, 9 minus 0 is 9. So that gives me the numerator of 9,715. Now looking at both of those values, I can see that they end in a 5 and a 0. So I am able to divide by 5, and that gives me 1,943 over 1,998. So that would be my simplest form fraction. Okay, I want you to go ahead and try the next 2 examples independently. Pause your video, I'm going to work them out, and then when we rejoin, you'll be able to check your work and see how you did. Okay, so pause your video right now. Okay, so hopefully you did your work. Go ahead and check your answers, see how you did. Usually the biggest question that I have with this unit, especially since I'm asking you not to use a calculator and to use, your skills of either long division and understanding common factors, is how do you know which is the biggest factor? And even for myself, I don't necessarily always know what the largest factor or the largest common factor is just off the top of my head. So I tried to show that in these last 2 examples where I looked at, for example, 54 over 90. Well, I know 54, one of the most common problems that we have would be 9 times 6. So then I think, okay, are either of those factors of 90? Well, obviously 9 is. So I divided by 9. And notice that didn't give me my fraction in simplest form, but it brought it down to digits that I am more familiar with, and that obviously is 6 and 10, and I know those are both even, so I can divide by 2. So it is a little bit of trial and error there. Please don't cheat yourself to just grab a calculator right away. Obviously, to help you out if you're like working through it, that's fine, but really challenge yourself to see what you can do without relying on that piece of technology. If you have any questions, I look forward to seeing you on our Zoom from 12:30 to 1:30. That link is in Google Classroom. Talk to you soon. Bye.